Our topic for lesson 17 is solving equations with inequalities and absolute value. Okay, so absolute value today. The distance from 0 to x on the number line, that is the definition of absolute value. Regardless of whether we go from Pierce to Norfolk or from Norfolk to Pierce, the distance we travel is always a positive amount, right? We're never going to say we traveled negative 15 miles. So that's the point that they're making at in the definition, regardless of whether you're going to the left on the number line or you're going to the right. At the end of the day, it's just going to be that positive value. Example number 1, absolute value of x minus 6 is equal to 4. We want to solve it, and then we also need to graph it as well. If we work with absolute value, and let's go back to a more basic definition. The absolute value of 3 is obviously 3. And the absolute value of negative 3 is obviously 3. Okay, so it's always going to be positive. The point I want to make is that something like x squared is equal to 9, what values can make that true?
3, -3.
Yeah, okay. So we always had two values that could work with that, right? So that's kind of the mindset that we have here with absolute value, is there's always going to be, more times than not, two possible solutions that we can come up with. So I like to do the arrow method. The first solution is just going to be whatever they give us. X minus 6 is equal to 4. The second solution is going to be the absolute value being the same, but now we're going to change the sign of the second value. And the example that I was really looking for was this one. This is what I wanted. What values of x make this true? 9 and negative 9. Yes. Okay. Notice two solutions that we can use with absolute value. And then from there, it's just your regular algebra. Add 6 to both sides to get 10. And then if we add 6 over here, negative 4 plus 6, we get 2. Thing with absolute value, you may want to check your answers, plug them back in and see if they work. 10 minus 6 is 4. The absolute value of 4 is definitely 4. 2 minus 6 is negative 4, but the absolute value of negative 4 is going to get us 4 as well. On your own, 3x plus 5, that absolute value is equal to negative 10. Abby has an answer already.
No solutions.
Why do you say that?
Because if you have an absolute value, you can't equal negative.
Yeah. So Abby happened to recognize it right away. And, that's awesome. Because, again, we can never take the absolute value of an expression and get a negative value. So if you recognize that right away, put no solutions. Now suppose you didn't recognize it, and you did your process, you did your two answers. That's where, when I made the comment, you want to go back and check to see if it works. That's when you would catch it. Okay? Suppose that you found it to be, I don't know, whatever it is, you plug it in and it doesn't work out for you. That's when you would realize, oh, none of these work. Problem D, absolute value of 3x plus 18 is equal to 6x. Possible two solutions again. The first one will be the same. The second one, even though they got an x out there with it, it's still just the opposite, so it's negative 6x. So there are your two equations. There are your possible two solutions. If we solve for x, we subtract 3x to both sides. So for the first one, I came up with x to be 6. And x is equal to negative 2. Do both of them work? let's check this. Hunter on over to Ashland, you guys are going to check 6, and then from Haley on over to Cole, you guys will check -2. Plug it back in and see what happens. So group A, what did we find out? The 6 works, okay. Checked. How about the -2? No, it does not. Okay, and if you notice, absolute value equal to this expression, well, what do I get when I take 6 times -2? Well, I get -12, and it goes back to the previous example. We can't take the absolute value of something and get a negative value. They're going to throw problems like this at you. The absolute value of 2x plus 4, then on the outside it's -5 is equal to 1. When you work with absolute values, before you do your arrows and you create your 2 equations, you have to isolate the absolute value. And what does that mean? Well, it means to get the absolute value by itself. So, notice before I get the absolute value by itself, I need to get rid of that -5. So I'm going to add 5 to both sides. I'm left with the absolute value of 2x plus 4 is equal to 6. Now it's by itself, and now I can do the 2 arrows. Let's have Ashlyn and Hunter. You guys will get the answer for this one. Haley and Cole, you guys will come up with the answer for the second one. I almost forgot negative value there, right? Okay. Okay, so first value we should have came up with was x is equal to 1. Over here, divide by 2. Is it okay if we came up with a negative value there? In this case, it is. We can plug back in. 2 times -5 is -10. -10 plus 4, help me out, -6. The absolute value of -6 is 6. 6 minus 5 gets us 1. With absolute value, there's 2 things that we need to talk about. It's called the intersection and the union, and or. Suppose we have the absolute value, and now we include our inequality symbols. Suppose we're dealing with our less than sign. The absolute value of something less than that value A. If we have that scenario, then that's considered to be an AND scenario. Which an AND scenario, again, is our compound inequality. Or the sandwich inequality, where we are sandwiched between those 2 values, negative A and A. The other scenario is when we have a greater than situation. This now indicates that we're dealing with an OR situation. Which means we can have the x's that are greater than A or x's that are less than A. Negative A. Sorry. This is a tough rule to memorize. Okay, I'm not gonna. It's not an overly big deal. Chances are this isn't the difference between you getting it right on the ACT or not, but it is something that we probably should know. How do we remember this? I believe it was. You guys remember Ethan Keeter? He came up with the idea that notice that this sign is a greater than sign. And instead of spelling greater with an ER, he decided he was going to spell it OR, greater, which indicated that was going to be an OR scenario. Take it for what it's worth. Real quick, let's just look at the parent function of the absolute value. Parent function just means the most basic form. If you're talking about linear equations, the most basic linear equation is y is equal to x. The most basic quadratic is y is equal to x squared. The most basic absolute value function is just the absolute value itself. And if we created our table, it starts off going to the right, just like a linear equation with the slope of 1 going through the origin. But now notice as I pick my x values to be negative, say -2 and -4, what happens when I plug in -2 here? What do I get? I get a +2. Same idea, absolute value of -4 is a +4. So if we look at those 2 points, 1, 2, 3, 4. Notice we get that line that goes up off towards the left now. So the thing I just wanted to bring to your attention, absolute value is the v function is what we like to call it. Okay, last couple. Solve x is -5 is less than or equal to 2. Go ahead on your own. The absolute value is by itself, so you can go ahead and do your 2 arrows right away. Here's the thing that I haven't talked about. What do you suppose we need to do with this inequality symbol for the second one? Yeah, we need to flip it. It was a less than sign, now it becomes a greater than sign, and we still carry the idea that we're going to do the opposite with that value on the outside. So don't forget that rule. If it's an equal sign, it doesn't really matter what we do. You know, equals is equals. So I get x is greater than 3. Let's see if we can identify the scenario here. And, or. Which one? It's an and situation. Very good. And again, if you go back to the beginning, absolute value less than sign indicated it's an and scenario. So you could write it this way, right? That's perfectly fine. The other way you could write it if you wanted to is like this. That's our compound inequality. Last one. Absolute value of 2x minus 5 is greater than 9. Oh, we probably should graph them. Go ahead and then we'll go back and talk about that. Those are the 2 that I'm coming up with. And or an or scenario. It is or because it's a greater than. Remember, greater has that OR. Last thing, let's go back to the graphing of it. Let's go back to example 2. It asks to graph the solution, and when we graph it, it's going to be on the number line. Because this is a compound inequality, just identify your two locations, 4, 5, 6, and 7. So we have 3 and 7. This right here indicates that it's going to be a closed circle. Again, closed circle. And I want all the x's in between. So just a nice straight line in between those 2 points. That's what I'll be looking for. If it's an OR scenario, we don't have to satisfy both conditions. We only have to satisfy one or the other. Our two values here are going to be -2 and 7. And that's good enough for me. You don't have to do anything more. We want the x's that are less than -2, so it's going to be open going to the left. We could also have the x values that are at 7 or greater than 7. Yeah.
Just on the one before, I'm just confused how you got x is greater than equal to 3. Because,
This one right here.
yeah, does that 5 stay positive? Or does that turn positive?
Whatever's in the absolute value stays whatever it is. So x minus 5, x minus 5. The thing that changes is what's not in the absolute value. So this 2 remains true there, but now we do the opposite when we do the second one. Same thing for 9 down below. First one remains true. Second one, it's the opposite, and we flip the inequality symbol. Let's only do 2 from the practice set. The 2 that I would like you to do are F and G